Welcome, welcome, welcome. My name's Blades, and yep, we're on exploration number 9, Qt shaders with GLSL. Let's explore. Look at this. This should put you off watching the rest of the video anyway. This is what a shader looks like in OpenGL. Lots and lots of functions with, wait for it. Yeah. You create shader, you load a shader, you put it all together. Oh my god, you put it all together and you make a shader. Well, yeah, that's just how I do it with OpenGL in AmberSL, a previous project which I'm still doing. My private and public projects are still ongoing with AmberSL. Not doing badly. Getting quite far now. Not as good as Qt, but hey ho, can't have everything, can I? There we go. Pop everything back to where it's supposed to be. How are we going to tackle that? Well, we're going to tackle it with Qt. We're going to boil all that lot down to about 5 lines of code. Yep, that's right, you heard me right. 5-ish, 6, maybe 7, I don't know. Let's find out. So, last time we left, we had test 2 dipping into OpenGL. Well, that's going to change. Too much OpenGL there. I mean, it was just a few lines, so I didn't mind too much. But we are supposed to be using Qt, so let's change that today. Let's change this over to Qt. Test2.h, please. Now, I've had to write notes on this because it's been a long time since I've done Qt, especially with OpenGL. So what have we got up at the moment? We've got 3.3 core. We'll definitely need, let's have a look, what shall we need? A shader program, yeah, better have one of those. Include, yep, Qt has its own shader stuff. Q open GL, and I'm looking for, that'll do, an OpenGL buffer. Yeah, we'll need one of those as well. Thanks. Good grief, I'm doing it by accident now. I'm programming this thing by complete accident. Open GL, and I want shader program. There's OpenGL shader and OpenGL shader program. I want program. Okay. So what we're gonna put here. We're going to change vertex buffer into what I really mean it to be. So I'm going to call that int position. We'll get rid of that. Don't need any more. But I've added 2 new things, so we better put those in. We're going to have a Q open. What am I doing? Paste. We can call this something simple. Program. That's going to be the program on the GPU. We're going to write it. And let's have a buffer as well. Q open GL buffer. We're going to need one of those to replace our pretty OpenGL that we made. So I'll have one of those. We'll call it how about position buffer? Yeah, why not? There we go. So those are me 3, 4, 4 variables. Yeah, after looking at what it was in OpenGL to do all of this, wow, that's not bad. I'm happy with that. Are you happy with that? Of course you are. I'm not going to bother messing with this part yet. There's no point really. Just get all the code right first of all, I think. Alright, so let's write our top bit, because we never finished it, did we? So let's do that, and comma. Let's put the other bits in now. So we've got nm program, and we're going to give that a bit of the old null pointer, I think he doodles. The position buffer is a bit weird. It doesn't behave itself. I've tried this before, so I'm just going to put straight in a new Q open GL buffer, and I'm not going to put brackets at the end because it doesn't behave itself when I tried to. So I'm just not going there, not playing with it today. I just want to do something correctly for once. We'll just set that to 0. Are we okay there? What? What's non-static about position? What is it on? Is it on drugs? Have I spelt something wrong again? Yes, I have. I haven't put M at the beginning. Typical. Thank you. I don't know. So we can leave this empty. That's a bit of a nuisance having that. I would prefer a null pointer there, but we can't have one. It has to be defined. Yeah, that buffer has to be generated. Well, it's not actually generated. That's a statement of intent rather than generation. There's no brackets there, so it's not generated, which is fine. What do we own here? Position buffer and program. Does position buffer, is this one of these weird ones that has a destroy member? Not sure actually. Let's find out. And all I want to do is, does it have a destroy? Yes, it does. I thought it was one of the weird ones. Interesting. That's probably why it does things differently, because it is different. I think it starts as a pointer and we just added a pointer to it or something rather bad. M program, we'll have to get rid of that, so that's just a delete. I know what that one is, that's just normal. I don't truthfully know the difference between the delete and the destroy, but you'll find this with Qt. Sometimes it'll do this destroy thingy, and it's usually when I can't put brackets on the end. That was an interesting thought. I should look into that more, shouldn't I? Should delve into the background of that. Interesting. I know the destroy does it differently. That takes away memory. So I wonder if that means it's on the graphics card. Probably. Well, the program's on the graphics card, or it will be. Oh well. Let's start here, shall we? Anyway, we'll start with the program. We'll get this out of the way with. Equals a new, and it's going to be a Q open GL shader thingy. Program. Again, doesn't seem to be sticking around, so I'm not going to put anything on the end of there either. All of that stuff you saw on the shader programs, we're going to do in this one line here. It's going to be program, and I do need some coffee now, so I'm going to have to type one-handed for a minute. And what we're going to do is we're going to add shader from source file. This is funny. I don't know why OpenGL doesn't do this, but it doesn't. You have to write your own. We'll have an OpenGL. What Muppet? I'm being attacked at the same time. An OpenGL shader, please. And we want it to be a Vertex shader, don't we? There it is, Vertex. And I'm going to call it, well, we will be calling it basic. And it will be a dot vert. There we go. That's all we have to put in. And it'll do everything for us. Qt, there are times when I just fall in love with this programming language. Because in C++, that's about 20 lines of code just vaporized. I'll copy it and do it all again. But this time I'll do it for fragment. I haven't talked about these yet, have I? Fragment a vertex shader and a fragment shader. We'll call that frag there. What do they do? Well, these are two of a possible number of shaders that you will find on your graphics card. Tessellation, geometry, God knows what. They all do different things or specialize in different things. The vertex shader will run once per vertex. Once, that's a vertex there. And a vertex doesn't just mean that information, but all the data that is with that vertex. A vertex is the whole thing. That's just position information, which is why I called it position information. It's a position buffer. It's not a vertex buffer, it's a position buffer, because those are positions. Different things, don't worry about it. And the fragment shader, if your triangle covers... I can show you. I've just broke the program, have I? Not really. Yes, I have. Never mind. If you've got a triangle up, for each of the pixels on your screen, the fragment shader will have run once. So if you've got a lovely big triangle on your screen, then it's going to be a few thousand times, 10, 20, 30, 40, 50, 500, depending on how many objects you've got. Quite a few per object, or quite a few per triangle. So it's a 1 to 1,000 relationship. So if you're going to write any code, prefer to write it in your vertex shader, please, not your fragment shader. You don't want these to slow down ever. So if you can, get it in the vertex. Some things you can't, obviously, but if you can, get it in there. And that's your interesting start to that. So the vertex takes our data in, the vertex shader. It then determines, or the outcome of it will be where the dot appears on screen, or that dot appears on screen. The fragment shader will run quite a few times through all of this lot and will determine the colours of the pixels. I'll come back to that because that's important. In between those two shaders, there is something else that happens. And of course, there's a few things that happen after those shaders and before those shaders. So we're not going to worry about those. That's another day, another dollar, another Patreon. Yeah. Program. What do we need to do with this program now? It's in GLSL, Graphics Library Shader Language. Well, I think we better link it all together. It's a bit like C, actually. It's more, looks a bit like C to me, just without the hash includes, because it's all static on the graphics card. So link it all together to make it into a binary, and program. I hit the wrong button here somewhere. I'm just trying to work out which one. Program. And what do we need to do with it now? We'll just bind it. We'll just activate it for now. There we go. That's it, all done. I was right, 5 lines of code. There is an extra one, and what we're going to have in our Vertex Shader is an attribute, if you remember, this attribute business here. So now that we're not using just a basic thingy, we actually have to discover what attributes we've got when we make it, when we make the shader. So I usually say separate from the program, but M position I'm not doing too well with this today. Brain slow. M position. I keep thinking I'm doing things wrong, and I'm completely right. Equals M underscore program. We just need to store and take note of where it's put it in the attribute list. So we're going to find out the attribute location, which is the bottom one there. We need to know where it's put it. I'll show you how to specify it when we do the shader, but that's perfectly okay. And we're going to call it position. But this has to match up with whatever we put in the shader. That variable name there and the variable name in the Vertex Shader have to match up. It has to find it and give back the location to that there M position, because we're about to rewrite this lot. Okay, so let's get to the first line that we're going to get rid of. That's this one. So let's get rid of that line and replace it with, you're going to love this, no more of this MGL arrow. This is better, a lot better. You can read it now, and you're going to understand better what we're doing. What we're actually doing at this point is we are going to create a buffer. And is it an E at the end? Why isn't it working? Because I didn't call it a buffer. Okay. And create. There we go. So we create our buffer. Then what do? We bind it. I don't think they've changed that, have they? Don't think they have. Soon find out. M position buffer. Let's find out. I think it's still bind. Yeah, it is. Semicolons. That one was easy. Now we need to send the buffer data, our data to the GPU. So I'm going to get rid of this line. That's OpenGL, and this is Qt. Out with the old, in with the new. I do love Qt, it's cute. So M underscore position buffer. And it's going to be allocate. That one. when we open the brackets, it's going to be, oh, we've got two choices. Int count or data and count. Well, I want data and count, so it's going to be verts, V-E-R-T-S, and count will be size of verts. How many brackets have I got here? Why do I need so many? I'm having problems with my brackets again today. Never mind. Don't look. A couple of extra things though that I'm going to do is this time I'm going to do it properly, so I don't mess. Actually, I should know. I'm going to leave it and show you the mess up first. No, I'm not. I'm just going to. If you leave it, it's a state machine. OpenGL is a state machine. So whatever state we leave it in, and at this point we've got a bound program running on the GPU. And if we leave it hanging like that, if we click over to test 1, we'll still have it running. So test 1 will start using our program. Yeah, it matters. It matters an awful lot with OpenGL. Always clear up with yourself before hitting that embrace and cancelling out anything like verts will just die at that point because it's local. Yeah, so we lose that out of our memory, which is nice because it just gets rid of the data that we don't want. We can delete also your shader sources. Not going to. I don't think it's that important, as important as this. It is if you're doing OpenGL, but not with Qt. Qt manages memory a damn sight better than we do. So position buffer. Do these in reverse order. So position buffer was last. So we do this first, and all we're going to do is release it, so that it's not going to be used by test 1, because we do have to think about having an multiple things happening. And of course we've got program, and for that we just have to release it. That's nice, isn't it? They called it the same thing. There we go. So I hope that makes sense. If we leave that in a bound state and we leave our buffer like active, it's going to flood over onto test 1, which wouldn't be a good thing. It could be a very, very bad thing. It would probably make test 1 fail. Maybe a crash even. You're never sure with these things. So that now we've done that, we actually have to add bits in here. And what do we got? Well, we'll get that buffer and program back. Which one should we do first? It doesn't really matter, I don't think, because it's a state machine. So I don't think it matters. I will do position, buffer, and we'll bind that. I will then do the program, and I've kept it all nice and easy in Qt. It's just bind that. There we go. Now what we got? Okay, enable the vertex trib. Okay, we can do that, and we do that using program. We do that by just enable, believe it or not, attribute array. There we go, and it's M position, which is why we needed it. It's the only reason why we needed it. So what we've done is we've taken a note of where it is here, and we're now enabling the correct attribute for the position, whereas before I just put 0 in by default and didn't know really why. Well, now we know why, so we know that it's hooking together now properly, which I think is a bit better than just guessing like I did before and got it right for some reason. Next line is tell it what the how we describe that lot. Again, we're going to use the program to do it with. So everything works through the program now, which I think is better. And this is going to be set attribute arrays. Oh, attribute buffer. We've enabled it. It's the buffer that we want, isn't it? Yeah. It says pointer. So buffer. Okay. And it's int location is again m position. And GLEnum type is a GL float. So now knows we've got GL floats. What's the next thing? Offset 0. We know about the offset. We spoke about that. Tuple size is 3 or 4. It can actually be 0, 1. No, sorry, it can be 1, 2, 3, or 4. In this case, it's 3 because we've got 3 making it 3 vertices make a triangle, not 4 vertices make a quad, which we could have used actually. And the stride is 0 again. That was a bit easier. I didn't really talk about stride too much. It's a distance between there, and there. If this was colour, if the first one was a position, and the second one was a colour, and the next one was a position, your stride would be from there to there, which would be 6 times size of a GL float, which is 6 times 4, 24. You put 24 in there. 24 bytes. Okay. I'm going to put space now, because we can't do anything about the next one. Now what we do is we shut down, and we do everything in reverse order. It's because it's a state machine. And it helps to do it this way, get it in case one of the states depends on another one of the states and you don't realise. It's always better to do it this way around. We don't have to do anything about the setting of an attribute. You don't unset an attribute buffer. So instead we'll do program. Oops, program. And what we'll do is we'll just disable something here, the attrib array, yeah. And again, we've got to tell it which one. You can see what's going to happen when we get more than one. Like we get quite a few. Like we'll have an index, we'll have what are they called? Tangents and God knows what's, and colours. Yes, we're going to have colours, textures. We're going to have everything. Eventually, eventually he says, quite quickly with Qt, because it's a lot easier to do. Program, well, it's just these two again, isn't it? So I did the program next. Release. And of course the last line is m_position buffer. Release. And it is as simple as that. Okay. There's a problem. We are missing 2 files. And we have to make them. So let's do that. Under test 2, add new, GLSL. I'm going for the desktop ones, it doesn't really matter. We'll do the Vertex Shader first, choose, name basic, source test 2, yeah, we need it in the same directory. Add it to Git, yep, please, and finish. And it's put a load of rubbish in for me. Well, thanks. Get rid of you lot. And frags, verts. No, this is the vert shader, isn't it? So we'll start at the top, and the first thing we do is we tell it what version we're using. And it's 3.3. And we're using Core. It doesn't mean that our graphics card isn't running 4.5, which in my case it is. Doesn't matter. That's the instruction set that we will be using. If we needed extra instructions, say from 4.0, then we just come back and we change it. Yeah, simple. Nothing going on but the rent. Layout. This is where it starts making sense. So we have to form a layout, and this is a location. Well, I'm going to call it location 0. You can call it whichever number you want, really. It's coming into the shader. It's a vector 4, because that's what we want, a vector 4. I'll tell you why in a minute. And it's called position. Semicolon. So that's a GLSL language. What we do is we form a layout up here. And you just put position there. So what you do is you form your layout. So you do your layout location 0 position, layout location 1 color, layout location 3 God knows what, because I haven't thought about it too much. Just close that down. But that is the most basic of basic vertex shaders that you can write. Save that. That's done. And now we want a... Does it come up? Yes, it does. It comes up under other files at the bottom. Oh, good. Now we will want test 2, please. Add new. We'll have a fragment shader. It puts .vert on the end for us, so we're alright. And that's going into test 2. Want it on Git. Finished. Frag color equals... Oh, didn't talk about it, did I? Said I was going to talk about it and didn't talk about it. Vec4 position. Why a Vec4 when we've only got three numbers coming in to represent each position? What happens with shaders in is it will add the 4th anyway. It'll do it for us. But it will, the 4th number that it will put in, it will be 1.0. And we'll go into that a lot further later on. But GL position is actually a Vec4. So if I hadn't have done that, I would have had to put, if I put Vec3 there, I would have had to put Vec4 open brackets position dot xyz close brackets, and that's how I would have had to have done it. But for ease of my eyes and to stop them from bleeding so much from watching TV screens, I'll just put position in like that. Thank you. There we go. Explained. Don't need. So it's just hash version 330 core. We'll make something up for the color. Let's make up a Vec4. And what color shall we have? I'm going to have 0.5 f, comma, 0.25 f, comma, 0.5 f. Remember to put the f's on to make sure the floats. What happens if you don't put the f on? It becomes a double. So you're wasting your memory. All of those will be in double memory. Yeah. So a complete waste of time doing that. GL frag color, blah blah blah. Yeah, that's okay. Like that one. Good. All happy? Are we all happy? Well, I've made a mistake, but are we all happy? Did anybody spot the mistake? Nah, it's alright. Compiler. Let's build it. Let's see how many real mistakes I made. My fingers weren't made for typing today. Oh, that many, huh? That's interesting. Oh, we haven't got the application output up. There we go. Unable to open file, basic vert. What's going on? It's there. Ah. But hold on a minute. The program that I'm running, where's that? Let's have a look, shall we? Come on, Fraz. Workspace, YouTube, Explore 3D. Ah, that's the program that's running. And you're right, there's no shader there. Oh, that's awkward. What can you do about it? Well, you can highlight those two there, and you can copy them over, is what you can do about it. Paste to items. Let's try again. Ah, there you go, it's working now. Ooh, that was a horrid colour, but hey ho. And it's not bleeding over. That's good news. I'll show you what happens if you don't put those two lines in. Basically you do test 2 and test 1. Oh, it's working now. Oh, you horrible person. Oh, that's because I'm clearing everything, isn't it? Oh. Hate you. Okay, be like that. Show me that I'm fibbing. Okay, is there anything that I could think of doing? Yes, there was. How's about cleaning this mess up? Don't need those two lines. Don't need that one. Don't need that one. There we go. It's not. It's a quite small file. In fact, it's a very small file for what it's doing, and it makes it look rather easy. But we do need to start adding more buffers and getting slightly more complicated on our fragment and verts. That's the only thing really there. Otherwise, I've got two programs running. Why? Thank you. Okay, let's get rid of those. Nearly fits on the whole. That's nearly just one screen. Oh dear, I really have shortened that down. Never mind. That's okay, that's a nice easy one. Fantastic, so I just want to close this lot down. That's test 2 done. So we've gone. Oh no, that's the wrong one. Let's have a look what we've got here. Let's just pop that up. there now. And we'll have another label, please. Which I can't see straight off. There it is. I'll get this lined up in a minute. There is an easy way of doing this, there must be. So, test 2 is open GL QT. It's open GL 3.3 with QT, and we better put a year on that. 2010. And let's see if we can actually spell it right there. There we go. I always forget to close my brackets. I've been doing that lately. I noticed I did it in another part of the program as well. I did fix it though. Why is Control S not working? Ah, because I haven't returned. This will need a colour thingy, won't it? What did I use last time? I think I just used that one. Yeah, that'll do. Yep. Lovely. And that should look okay now. Let's check it all out. Yeah, that looks okay. Ah, right. Nice. So I've gone from 1997 to 2010, and things are looking good. Nice one. So we've now got test 1 and test 2. So I think it's obvious what happens next. You go on to test 3, where you develop more. Yes, and you start flexing your muscles a little bit. But at this stage you should also start thinking about the engine. And really, what I am thinking about is like starting, well, we've got input already. Because if we're doing engine, what we can do as well is a camera. And we could do quite a lot more. So what we're going to be talking about, I believe, in our next episode is something called MVP, Model View and Projection. I better note that down. So we've done Qt shaders with GLSL. It was a lot easier than people think. So #10. I will have MVP. Not most valuable player, but model view projection, that kind of thing. We've actually got a projection already. That's a perspective that I did to stop that warning happening. So I've actually got a bit of that already. So the P's already done. It's just the M and the V we've got to do. And that's it. The model comes from our data positions. The view comes from the camera. And the projection comes from that exploration bit that we did. Oh, I've got the burpees. I've lost everything now. Yeah, resize GL. That's your P. Your perspective aspect ratio, which is your TV screen sizes. 5 down and 9 across. 9 by 5 on this one. There we go. And if anybody's really wondering, you can, on my YouTube channel, hit that Patreon button that's just there. Pop over to Amber Skies, have a look at my Qt 3D stuff, not Qt OpenGL stuff, which is this. Otherwise, catch you next episode. Take care and have fun.